Good morning, everybody. This is Tom again, and I want to welcome you all to the next installment of my Tips and Tricks webinar series. Today we're going to be discussing improving the reliability of your BOD test results. I want to thank you all for taking the time out to be with me. I know you're all real busy, especially with spring around the corner and samples coming in. You took your time out to learn something today, so hopefully this will be as beneficial for you as it is for me. For those of you who don't know me, I'm Tom Wadera. I'm a technical manager here at ERA. I've been here for about 16 years now. I was a product manager for quite a while, and now I've moved on to be a technical manager. Been delivering our webinar series for quite some time now, so I hope you've enjoyed them. So a little bit about ERA before we get started. ERA was founded back in 1977. Currently, we're located in beautiful Golden, Colorado, right at the foothills of the Rocky Mountains. We support more than 7,000 laboratories providing proficiency testing and certified reference materials for them. And right now we service laboratories in more than 80 countries. ERA provides certified reference materials and proficiency testing samples for a wide variety of matrices, including wastewater, drinking water, soils, air and emissions, microbiology, and radiochemistry. ERA also provides a whole host of custom standards. So if there's something in our catalog you don't see and you want, give us a call and we can make it for you. We are accredited by A2LA as a 17043 provider of PT samples. We are also accredited for Guide 34 and as a laboratory under ISO Guide 17025. So today, we're going to talk about BOD. For our agenda, we're going to discuss the Lac criteria and the acceptance limits. We'll go through an overview of method 5210B, which is the standard method for BOD analysis. And then we'll go into some detail discussing tips and tricks to help us with the reliability of our analyses and to help us with some upcoming proficiency testing studies. At the end, I'll provide you with some contact information for myself in case you have any questions or you want some further discussion or further clarification of things. I'm always available to help you, so anytime you need some help, give me a call or send me an email. So, BOD on the surface. Seems like such a straightforward test. You dilute up some samples in BOD bottles. You seed them or you don't seed them. You take an initial DO reading, incubate your sample for 5 days, take a final DO reading. Seems pretty straightforward. However, there are so many factors in BOD testing that can affect the DO uptake. It makes BOD one of the more difficult tests, I think, in environmental analyses. These factors can contribute to potential erroneous readings when testing your effluents or your field samples if you're a commercial lab. And they can cause tremendous headaches when performing proficiency testing or our PT analyses. So I know a lot of you are preparing for your DMR QA for this year, so we're going to talk an awful lot about things that can help us with that. Really knowing and monitoring what I call these pitfalls in BOD analyses and having a good understanding of the proficiency testing criteria can really dramatically increase the reliability of your BOD test results. So that's what we're going to discuss today. And I want to let you know, as with my past tips and tricks webinars, it's not designed to introduce you to how to run the BOD tests because you already know how to do that. But really we'll focus on education, specifically education of the PT criteria and of the method itself and how to avoid some of our pitfalls. Alrighty. So let's jump right into the Lac criteria. Again, most of you are getting ready for your DMR QA 36 or possibly some of your WP studies. So what I want to do is to kind of give you an idea from a proficiency testing standpoint where all this criteria comes from. How do I get judged? Who decides whether my tests pass or fail? Where does all this information come from? I get those questions a lot, and I'd like to clear up that for you. Because this information is public information, it can be found on NELAC's website at nelac-institute.org. We can utilize this information to help us with our proficiency testing. So let's go over the NELAC acceptance limits, the NELAC criteria. What is this and where does it come from? So over the past 40 years or so since the EPA has been in existence, there have been proficiency testing studies done. All the data that's collected in these proficiency testing studies go into a central database, where this database then collects the information, generates what they call expected acceptance recoveries, and generate what they call expected standard deviations, which is a variability in the method. So if you've run proficiency tests before, if you've done DMR/QA in the past, your data is in this database, and it helps to generate these regression equations. So what the EPA does is they take this information and they generate what they call an expected recovery. So if you look at your screen now, you're going to see 4 numbers. There's an A factor, a B factor, a C factor, and a D factor. These factors all come into play when generating what the acceptance limits will be for your tests. So the A and the B factors are used to calculate out what's called an expected recovery. Then the C and the D factors are used to calculate what's called an expected standard deviation. For wastewater analyses, which BOD is part of, the acceptance limits are going to be plus or minus 3 times a standard deviation around what the expected recovery is, which is what we call a 99% confidence interval. And what that doesn't mean is that 99% of you will pass. What it means is that the data used to collect and generate these regression equations, 99% of that fits into this criteria. Now, as with past tests, and most specifically with BOD, you're being judged against how much of the analyte you're expected to recover and not how much we spike in. BOD is a pretty extreme case of that. And for those of you who run your GGA standards, you're already aware of this. So when you make your GGA standards, you spike it at 300 milligrams per liter. You put 150 milligrams of glucose and 150 milligrams of glutamic acid into your GGA and run that. So technically, if you could recover 100% of BOD, you should get back 300. But as those of you who run that as part of your QC for your method know, you're expected to get back 198, which is about 63 to 64% of what you spike into that. So the EPA takes that into consideration because that's the limitations of the method. So if you look at your A factor, what that is a decimal representation of the expected recovery, which is 0.6237 or about 62%. So you're expected to get back 62%. That's what you'll be judged upon. If you get evaluated against 100%, just about everybody's going to fail, so it's not fair to you. The B factor is a concentration dependence factor, as with a lot of tests, not so specifically with BOD, and I'll explain why, but with most tests, it's much easier to recover something at the higher end of the concentration range than it is at the lower end of the concentration range. So that factor takes that into consideration. Then we look at our C and D factors, which generate our standard deviation, or the variability in the method. So our C factor is a decimal representation of the expected standard deviation. So if you look here, our C factor of 0.0928 means you're going to get about 9.3% or so variability. And then our D factor is a concentration dependence factor for the variability in the concentration that we're going to spike it at. So if we're expecting roughly 9% standard deviation, the acceptance limits will be plus or minus 3 times that value, or roughly 27 to say 30%. So you're going to be statistically evaluated on about 62% recovery with about plus or minus 30% standard deviation in that. And again, it's for fairness to make sure that you're being judged about what you can get back and not what is spiked into the sample. So the sample itself for the DMR/QA or for your WP studies can be made anywhere between 18 and 230 milligrams of BOD per liter. So we can utilize this information to do some calculations. So if the sample was made at the absolute lowest end of the range, or 18 milligrams per liter, your acceptance limits would be 27.4 to 105%. At the higher end, which is the absolute maximum we can make this standard at, or 230 milligrams per liter, your acceptance limits would be 34 to 91%. So if you look at, especially on the higher end, the acceptance limits don't even encompass 100% recovery. And again, that's because you're only expected to get back 62%. And to be fair in the evaluation, you want to make sure that you're being judged on what you can get back and not what we put in. So where this becomes valuable information for us is we can take this information and calculate out an absolute minimum value for BOD that we could report on our PT and pass. We can calculate out an absolute maximum value for our BOD that we can report and still pass. So where we can use this information is to calculate what I call a working range. So that values within that working range could be potentially acceptable values. Values outside that working range will absolutely fail your PT, so that you won't want to report that. What that means is that there's something going wrong with your analysis. You want to take some time to troubleshoot, try to figure out what's going wrong, and correct that before you report your data. So let's go through this minimum calculation. And what that means is that if we were to make the sample for your DMRQA or your WP at the absolute minimum value of 18 milligrams per liter, we can go through our calculations, calculate out an expected recovery, which would be the value we made it at, of 18, times that A factor and add to it that B factor. So what that tells us is if I spike that sample at 18 milligrams per liter, you should get back in your BOD reading 11.9. We can then use the C and D factors to calculate out the expected standard deviation. So we again take the value that we make it at 18, we multiply it by the C factor, add to it the D factor. So our expected standard deviation, or the expected variability in the results of that low end, would be 2.33 milligrams per liter. And as I had mentioned, your acceptance limits will be plus or minus 3 times that value. So we take that value, multiply it by 3, and we get a value of 7. So what we can do is take this information to calculate out the absolute minimum value we can report and still potentially pass our BOD, which is 11.93, our expected recovery, minus a 7, which is our 3 standard deviations. So we have a value of 4.93. So that's, if I were to make that sample for your DMRQA at 18, the lowest value you could report would be 4.93 and still pass. So now what we can do is do the exact opposite and calculate out what our expected maximum would be. So we go through the same calculations that we had, calculate out our standard deviation, our expected recovery, make our 3 standard deviation limit, and notice that if we make this at 230, the absolute highest value you can report and still have a value to pass your BOD would be 210. So what we can do is take these two numbers and calculate out a working concentration range. This is what I mean about having some education on the acceptance limits or knowing what you're up against when you're running your DMRQA sample. So the working concentration range would be 4.93 to 210 milligrams per liter. What that we can do with that information to help us is if you're running your BODs and you get a sample value that's outside of that working range, no matter what we spike the sample at, you're going to fail your DMRQA, you're going to fail your WP. So don't report that value. What that's telling us is something is going wrong in our test. We're going to go through a lot of the specifics of the technical part of the method to try to help us if we want to troubleshoot what could possibly have gone wrong. But if you've got a value outside of those numbers, you're going to fail your DMRQA, so don't report that number. What I want to make sure that we all understand as well is just because we have a number inside of that range doesn't automatically mean we're going to pass our proficiency test. What that means is that we have a potential to pass. So if you're reporting a value somewhere near the upper end of that 210, but we spike it down at the bottom end, you're still going to fail. But what this does is tell you exactly a value that will definitely fail. And if you get a value outside of that range, let's do some troubleshooting of our method and try to figure out where we went wrong. Okay, I'm more than happy to help you out with that. So if you want to give me a call, send me an email, I'll do whatever I can to help troubleshoot. All right, so let's start out with just a quick overview of the method. Again, as I had mentioned at the beginning, it's pretty straightforward, but there's a lot of pitfalls that we need to avoid. So a quick overview of the standard method 5210B, which is your 5-day BOD. So you want to adjust your sample according to your version of standard methods. Now, I know that we're all using several different revisions. You could be using anywhere probably from the 19th to the 23rd edition. And there is a slightly different pH requirement. So make sure that you're adjusting that sample, whether it's your DMRQA, whether it's your effluent, whether it's your raw, whether it's a field sample, to the correct pH. Some of the versions of the method say it should be 7 to 7.2. Some say 6.5 to 7.5. So check your current revision or check your current work procedure, your current standard operating procedure. Then it tells you to prepare and check your dilution water. Quality dilution water is very important for the successful analysis of BOD. We'll discuss that a little bit later on as well. You want to perform necessary dilutions. You need to make sure you run a series of dilutions to make sure that one or more of those dilutions will meet your method criteria for dissolved oxygen uptake. If necessary, make sure you seed those samples. Some samples need seeding, some don't, and we'll talk about that. And then make sure you fill your bottles properly. Make sure that you have excess liquid at the top of the bottle between the stopper and the flange of your bottle to make sure that you're not having any oxygen uptake into the sample during your incubation period. Make sure you're including all necessary method QC, specifically that GGA standard. We'll talk about some others as well. QC is very important for quality analysis because it gives you an opportunity to check against a known value to make sure that your test and your procedure is proper. You want to take those initial DO readings. We'll discuss a little bit about what we should see for DO readings. We want to make sure that our value is high enough, that we allow enough DO uptake to meet our method requirements, but not too high that we have supersaturated DO. We'll discuss how to take care of that. Incubate that for 5 days at 20 degrees C. We want to make sure we do it for the right time at the right temperature. We'll discuss what could happen if we're not using the right time and the right temperature. And it tells you to take that final DO reading so we see what our uptake is and that we can do our calculations properly. We want to take into consideration that any seed we use will have BOD in it. We need to correct for that because it's not part of the sample, it's part of the seed. So let's get right into our tips and tricks. And you're going to hear this a lot from me, especially if you give me a call to talk about some technical tips. There are many, many places for things to go wrong for BOD analysis. If you're doing your BOD on your proficiency testing, the acceptance limits reflect this. BOD has one of the widest sets of acceptance limits in all of DMRQA testing. Taking care to ensure that your analysis is going correctly can solidify that analysis, leave you within the acceptance range, or make sure that your analysis is proper so that if you're discharging your effluent back into the environment, saying it's clean, you know that it's clean. So I'll bring that up a couple of times because there are a lot of places for things to go wrong in what we consider to be a relatively simple method. So first of those tips and tricks, let's talk about the chemicals that we use in the test. Preparation of those chemicals is a big key to your success. Chemicals have to be fresh and contaminant-free. If you're manufacturing your dilution water nutrients yourself, you've got 4 different chemicals to prepare. You want to make sure that you're preparing them properly and that the water that you're using to prepare them is clean and free of potential contaminants or potential interferences. The preparation of the individual chemicals is covered in Section 3 of Method 5210. It gives you a pretty good detail of how to make those, the 4 different nutrients that you're going to spike in. However, your nutrient water, the nutrients for that, are also available commercially. And the ones that I've used in the past, I've had tremendous success with. And it makes life a lot easier where you just take your source water, you pop in these commercially available nutrients to make your nutrient water. It makes life a lot easier for you. Gives you the opportunity to remove one potential source of error in manufacturing those yourself. So when we're talking about our source water, we must make sure that that source water is free from two things especially. One are your heavy metals, especially copper. And the second is chlorine, as both of those can interfere and result in low BOD results for your BOD. So chlorine is a big one because it's a disinfectant and it will have a dramatic effect on the microorganisms that are in the seed that you add to the sample or the microorganisms that could be in your raw. So remember, when you're making up your dilution water, the source water that you use is important to not be to be free of both chlorine and those heavy metals, and also not to contain any microbes themselves. Distilled water works great. If you have distilled water available, that really works good for you, making sure that the source of your distilled water is not from copper kettles, because you don't want to introduce any copper in there. Deionized water will also work well as long as you're sure that it's free of organics and it's free of microorganisms. There is a potential for both in deionized water. So what's most important, especially if you're using deionized water, you want to make sure you check that nutrient water that you're making from your source water to make sure that it's of the proper quality for the test, which is less than 0.2 milligrams per liter of BOD. So if it happens to be above that, it's letting you know that the quality of that water is not great and it could have an effect on your analyses. So if you're getting values of BOD greater than 0.2 milligrams per liter, let's discard that water and let's use something fresh. Make sure that we're using water that's of the quality. Okay. The dilution water that you make, once you add the nutrients to that, should be made fresh each day. That will help us to assure the best results that we get. And as I know from working in a commercial lab, it's not always easy to do that every day. So you can use it for longer than that time period if you can't make it fresh every day. Just make sure that your dilution water blank is always going to show your BOD less than 0.2 milligrams per liter to keep any potential interferences from happening in your test. So we want to make sure that we check that dilution water, make sure that the dilution water is proper, and make sure that our dilution water puts us in a good initial DO range so that we can have, during our incubation, a good DO uptake to help us meet the method criteria. So I would recommend making sure that your levels of DO in that dilution water and that initial check, somewhere between 7 and 9. That's good quality water for you. That gives you the best chance for meeting your method criteria, which is DO uptake of at least 2 milligrams per liter and residual DO left over of at least 1 milligram per liter. So generally speaking, water is going to be somewhere between 7.5 to 8.5 or so, even up to 9, naturally in the waters, unless that water is real cold or you've got some kind of contamination in that, in which case you want to do something to rectify that. If your DO is too high, super saturated, all you have to do is stir or shake it, releases some of the air in it, which should drop that DO back down into a good working range for you. In the case that you're on the other end and you don't have enough DO, if it's less than 7, you're not leaving yourself a whole lot of room there. All you have to do is aerate that sample somehow. Bubble some oxygen in there or plug it up with some plugs in there to allow to air from the atmosphere to get in there. Get yourself to that level of 7 to 9. So then we've got to prepare the sample. So whether we're analyzing a field sample, whether we're doing our raw, whether we're doing our effluent, or whether we're preparing a PT sample for analysis, we want to make sure that that sample is diluted properly, most notably making sure that we adjust our pH according to our method requirements. Okay, again, we discussed standard methods having a couple of different requirements in there. either 7 to 7.2 or 6.5 to 7.5. You want to make sure that pH is adjusted properly. And the reasoning for that is that you've got microorganisms in your sample. If the pH is too acidic, it's too low, or too basic, it's too high, it's going to distress those microorganisms. It's going to affect the DO uptake and generally will give you low readings. So you want to make sure that you don't have that happen. It's extremely important. When you're running your PT samples, and I can tell you specifically from ERA, our PT sample is acid preserved to prevent any kind of microbial growth in it. So once you dilute that sample up, you're going to have a pH of about 3 to 4. If you were to add your seed directly to that, you're going to kill those microorganisms and you won't get any DO uptake. You won't get any oxygen depletion in that at all. So you want to make sure that you properly prepare that for your pH. I highly recommend using roughly a 0.2 normal sodium hydroxide solution. It's dilute enough where you can raise that pH slowly into your range, but it's strong enough where you're not adding too much volume to your sample and not affecting that. A 0.2 normal sodium hydroxide solution, if you have sodium hydroxide pellets in your laboratory, 8 grams of that to a liter will give you a 0.2 normal solution. And again, it's a good working concentration. If it's too concentrated, what's going to happen is you start adding it dropwise at a time. Your pH will rise slowly to about 4, 4.5. All of a sudden, it's going to shoot up to 10, and you're past your range. Well, then you're stuck adding some acid to the sample, and then it shoots back down. So to avoid that up and down adjustment of the pH, that concentration seems to work real well. If you happen to be purchasing your PT sample from ERA and you don't have the ability to make it or you don't have any in your laboratory, we will happily provide some of that 0.2 normal sodium hydroxide for you free of charge. So when you order your sample, just ask for the pH adjusting solution for your BOD and we'll send some to you. One thing to remember too, I get a lot of questions that say, hey, I shot above my pH, what am I supposed to do? It's perfectly acceptable to add a little bit of dilute acid to drop it down. Even sometimes if you go above and below and above and below, the most important thing is before you add that seed to your sample that your pH is in the range. You also want to make sure that you're performing a series of dilutions. Method 5210 suggests at least 3 different dilutions. If you want to do more, that's perfectly fine. The most important thing is you want to perform a series of dilutions through there to make sure that at least one or more of those dilutions meets your method requirements. You want to make sure that you have enough sample in there, enough nutrients in there to give you a DO uptake of at least 2 milligrams per liter. But you want to make sure that you don't add too much, because if you add too much, then you don't meet the method requirements of having at least 1 milligram residual. The reason you want to have that 1 milligram residual is you want to make sure that you don't go to full depletion. If you go to full depletion, it's going to affect your results. So remember that your DMR QA BOD is going to be somewhere between 18 and 230 milligrams per liter. So during the course of the PT, I can't tell you what dilutions to do. But what I can do is let you know that use your effluents, use your influence, use some field samples as a good guide. If you've got field samples or effluents that are down near the lower end of that range, and you generally use a certain amount of that sample, 50 milliliters, 7,500 milliliters, it's a good guide to go by to let you know how much to use if we're at the low end. Same thing at the upper end. Some of your raw influence can get up to that higher values or even higher. So use your raw, use some industrial wastewaters maybe if you're running those, to give you an idea about how much sample to use if you're at the upper end. Say you do 5, 10, 15, 20 milliliters. Gives you a working range there. The more dilutions you can do, the better it is, because the more likely that you're going to run into a dilution that's going to hit your method requirements. And then make sure you fill that BOD bottle properly. Don't ever, like I said, don't ever add seed to a sample that doesn't have a pH of 7. A lot of times the nutrient water that you use, because it's at a pH of 7, if you're doing a big enough dilution, can help set that pH at a good value for you. Make sure that the pH is at proper value before you add your seed to the sample so that you're not distressing the microorganisms in the seed. and then make sure that you fill that bottle up again all the way to the top when you're doing your incubation. So you're going to test your initial DO. If you happen to spill some out, you want to fill it all the way up to the top, stopper it, then make sure in the neck of that flask that you've got additional water in there, additional dilution water, so that you have a vapor barrier. Because if you don't have that barrier, once you put it into the incubation, if that dries out, you're leaving a place for extra oxygen to get into the sample through the air. The more oxygen you introduce into that air, the less oxygen uptake you're going to read in your sample and the lower the values are going to be. So that's a real important thing to make sure. Make sure too that you protect that flange using either plastic cups, I know that they make are good, or some foil to put over the top to make sure that you've always got that water vapor barrier in there. So again, we talked about seeding. So depending on whether you're running your proficiency sample or you're running your in-house samples, you may or may not need to seed that sample. So a lot of raw wastes that come in, a lot of untreated effluents have enough seed in them, have enough microorganisms in there where additional seeding isn't necessary. But if you've got treated waste, especially if you're treating it with chlorine or your proficiency samples, they won't have seed in them. Thus, there's no microorganisms in your sample to uptake the DO, so you're going to have to seed them prior to analysis. The 5210 method talks a little bit about seeding samples individually. I would highly recommend that. I've talked to a lot of people in the past who have had issues with getting consistent results, and what they're doing is they're seeding their dilution water. They're seeding that nutrient water. But as you do varying degrees of dilutions in there, if you seed that dilution water, you're also putting various amounts of seed in there. The seed contains DO, and it's going to have a pretty dramatic effect on your calculations. So if you seed that nutrient water as opposed to seeding each individual bottle, you're going to put varying amounts of seed in there, and it's going to give you inconsistent results. So I would highly recommend making sure that we seed each bottle. So seed, making sure that that seed is of good quality and it's consistent. You want to make sure that it's not overloaded with nitrifying bacteria, but has a mix of both nitrifying and carbonaceous bacteria so that you'll have a good uptake and a good consistent uptake. The amount of seed you're going to use is going to depend on the strength of the seed itself. So a lot of wastewater that comes in, a lot of your raw influent and your non-chlorinated effluents all have a really good amount of microorganisms in that, all make really good seeds. Seed is also available commercially, and they call it polyseed or a polymer seed. The polymer seeds are generally of good quality, but they're not as strong as a lot of your raw seeds would be. So if you choose to use a polymer seed, you want to make sure that you use a little bit more of that seed as it's not as strong. So what's important to remember is to make sure that you're using the proper amount of seed. Not enough seed in it isn't going to give you enough depletion. Okay? And too much seed will give you too much depletion. It's going to give you high results. So in order to make sure that the quality of your seed is good, you want to run a seed control. So that seed control should give you a DO uptake of somewhere between 0.6 and 1 milligram per liter. That'll let you know that your seed is not only good, but you're using the appropriate amount of seed. And some of you will run seed controls with varying amounts of seed in it to see what gives you the best result. I highly recommend that. It's an excellent practice. Remember that your seed contains BOD, so you need to make sure that you're accounting for that when you do your final calculations. So let's talk about the actual procedure itself. Okay, so once your samples are prepared, you want to perform that initial DO testing. And again, ideally, your DO should be somewhere between 7 and 9. If it's too high and it's super saturated, all you need to do is really shake that sample, tap it, swirl it. It'll help release some of the DO, and you can get yourself into a proper working DO. Again, if your DO is too low, doesn't leave you enough room in your method criteria to give you appreciable DO uptake. So you want to add some to that, make sure you get it into the right range. Make sure that your DO probe, if you're doing it by either membrane electrode or the new RDOs or the new LDO, make sure that your electrode is properly maintained. Make sure that you do the maintenance on it. Make sure it's calibrated properly. One thing to help ensure that your DO tests are accurate is to do a check, a quality control check, or a reference material. There are dissolved oxygen standards available. ERA has just introduced one in 2016 that will help you to check to make sure that that DO probe is working properly. You can also, if you're doing the Winkler titrations, run a DO check standard to make sure that your titration is working properly. We discussed a little bit earlier about temperature and time for the incubation process. So once you do your initial DO test, make sure that you've got additional water, additional dilution water on the neck of that flask so that you're not allowing any air to get into your sample. Incubating at the right temperature for the right time is unbelievably critical in the quality of this test. So make sure that your incubator, 20 degrees plus or minus 1. If the temperature gets too high, it's going to speed up the activity of those microorganisms, and it's going to have a result of too much DO uptake and too high results. If the temperature is too low, it's going to slow down the activity of those microorganisms. If that happens, you're going to get too little uptake and too low results. Make sure that it's at the right temperature and monitor that temperature continuously throughout your tests. Also, making sure that you incubate it for the right time. There is a little bit of buffer in that. It's 5 days plus or minus 6 hours. But again, not incubating it long enough isn't going to give you enough proper uptake. You'll get low numbers. Incubating it too long is going to allow too much time for DO uptake, and it's going to allow for too high results. So that's critical to make sure that you're doing it for the right time and not just the right temperature. Also, make sure, especially if you're running your DMRQA, it's a 5-day test. Allow yourself enough time for that 5-day incubation. Also, if your test happens to go wrong, something's not right in that, make sure you're leaving enough time to do the test a second time. So don't wait till right at the end of your PT test to start your sample. Doesn't allow any time for anything to go wrong. Make sure when you perform that final DO test, okay, you're meeting your method criteria. Minimum of 2 milligram per liter of DO uptake and at least 1 milligram per liter of residual left over. Not meeting that method criteria is going to cause erroneous results. So ideally, you want to have at least 1, if not more than 1. If you've got more than 1 sample that meets that method criteria, make sure that those 2 results agree. Because if your test is done properly, you meet the method criteria, those 2 or more results should all give you about the same value of DO. So if you're getting 2 samples that meet your method criteria and you're getting 50 for one and 80 for another, something's going on that's causing that erroneous results. Could be something with your seed, could be something with air uptake. So make sure that you're getting good reproducibility. And again, critical to make sure that your method criteria are met. So let's talk a little bit about quality control. Quality control is extremely important when we're talking about the reliability of our results. So there's a number of things that can help us with the quality control. We talked about the temperature, making sure that the temperature is consistent and proper. We talked about the time. We talked about your seeds. We talked about making sure that the quality of your source water is good. All of these come into play for the quality control of your process. Some of the things that people don't think about as much when they're talking about quality control is to making sure that your probe is properly maintained. If you're using the old membrane electrodes, okay, those gold plates need to be cleaned periodically. The membrane itself needs to be changed. You also need to make sure that you don't have an awful lot of drift during the course of your test, because remember, you're measuring DO at the beginning, DO at the end. You're going to have multiply that by factors of the seed, factors of how much sample you're using. If your DO is drifting, if your electrode is drifting, during the course of the analysis, that can have a dramatic effect on your calculations. So if you're using that membrane electrode method, make sure that you run your water blanks at the beginning, periodically through your run, and at the end of the run. And try to assure that your readings don't drift by more than about 0.15 milligrams per liter. Anything more than that is showing drift in the analysis, and it's going to result in erroneous calculations. Again, make sure that those DO measurements are accurate. How do I know that they're accurate? Okay. Again, dissolved oxygen quality control samples. They're a wonderful thing, comes with a certificate of analysis, lets you know how much DO is supposed to be in that sample, and gives you a check to make sure that your probe is accurate. Another important thing for quality control, because it's written in the method, is your GGA standard. If you're not running that, you don't know if you're doing a proper incubation. You don't know if you're doing the test properly. That GGA standard, if you make it up yourself, it's also available from commercial vendors. Will let you know how much BOD you're supposed to get back. 198 plus or minus 30.5. If you're outside of that range, you want to do some troubleshooting. If I'm higher, what's causing those higher results? Am I incubating it too hot? Do I have too much seed? Did I incubate too long? What's going on there? Same thing on the other end. If my GGA standard's coming up low, what's going on? Am I not putting enough seed in there? Did I incubate at too cold a temperature? Think about those types of things. What can cause that to go wrong? Because generally speaking, if your GGA standard is out of control, then your samples are going to be out of control. And if you're trying to report your effluent concentration on your DMR and your GGA is out of control, how do you know that the value is accurate? And when you're talking about discharging water back into your environment, that's going to affect the fish downstream. It's going to possibly affect people who are walking in that water, drinking that water. You want to make sure that your results are accurate. The GGA standard can help you with that. Same thing with your proficiency test. If your GGA standard is out of control, it's probably pretty likely that your proficiency test is going to be out of control as well. So make sure you're running that. Make sure that you're making it up properly. There are commercially available GGA standards. The BOD standard that ERA supplies is a GGA standard. It's made up with glucose and glutamic acid. We do sell those as quality control samples. If you want to run those along with your sample, even better for your quality control. You've got an outside source certifying that sample for you. So if your GGA is out, it takes away the one variable, well, did I make my GGA standard up properly? So quality control is a very, very important measure when we're talking about improving the reliability of our results. Couple of things to think about. Avoiding surprises. Remember what we talked about way at the beginning, that there's so many places for things to go wrong. Allow time for things to go wrong. If you're running your DMR QA sample or your WP sample, run those analyses as soon as possible, because ultimately and inevitably things go wrong. If something goes wrong with your process and you need an additional 5 days to rerun the test, the sooner you run that sample, the more time you're going to have to redo it. I've talked to many people who have done their analysis or in process or doing analyses. All of a sudden something goes wrong in your plant. There's a flood, there's a chemical contamination going on, and all of a sudden, hey, I can't run my DMR because I'm doing something else. Or your electrode goes bad, something's going wrong with your process, your chemicals are bad. Make sure that you allow time for things to go wrong. We talked about a lot of things that could potentially go wrong with this test. Allow time for things to go wrong. Best thing you can do too, establish a routine quality control process with the use of certified reference materials, that GGA standard. Whether you make it up yourself, whether you purchase it from an outside source, running that every time you do your BOD tests will help you to ensure the reliability of your results, ensure that everything is accurate. So I hope you enjoyed our talk today. I appreciate, again, you taking the time out to be with me. I know you're all real busy, and I hope that this was helpful for you. I hope that you were able to take something away from this. Again, here's my contact information. You could either call me directly or you can email me. If you ever have any questions or you want clarification, you want some help troubleshooting, give me a call. I'm here to help. I'm more than happy to help you. If you want to contact ERA to order samples or send an email to our info box, here's all our information that you can do that as well. Thank you very much for taking your time out to be with me today. I appreciate it. If you're using this webinar to prepare for DMR QA, it opens in about a month. I wish you guys all the best of luck. If you need help during the course of your DMR or your WP, give me a call. Have a great day, everybody.